Yeah, we're going to talk about API services, and then I'm going to move into continuous integration and continuous development, and how that's done with Talend. Let me bring up just a few slides to sort of introduce API services. So we're going to cover basically, what it is. It's very new. The design first, contract first approach, how you actually sort of turn that into implementation, and how you test your APIs using this tool. We're going to move at a fair clip because we need to get to the continuous integration and continuous development piece as well. So it's really about trying to industrialize your API implementation and make that as easy as possible. So we have a new tool that's completely graphical to design your API, which is creating your contract. And what it does is it decouples the design process from the implementation. So you can get to work designing your API, and you can use sample. You'll see this when I show it in the product. You can use sample, JSON, for example, so that people can then test against the design that you've done, but the actual implementation can happen separately. So these are the stages of the delivery. You go ahead and you design it in the tool. I'll be showing you that shortly. You implement it in Studio. So if you're familiar with Studio, which most of you probably are, that piece hasn't really changed much, but I'll show you what is different. And then you use the testing tool to sort of make sure that your API is functioning properly. And along with that, you get documentation so that people can consume it more easily. And then you go about deploying it. So I'll show you how to deploy in the Talent Management Console once you've designed it. So let's just go into the demo. So I'm logged in currently to the portal, and I'm selecting the API designer. This is where you go about defining your endpoint. So this is my REST API endpoint, and as you can see, I've got a number of operations that I want to include. It's very easy to add these. You basically just, it's a nice ergonomic display. Hit plus, put the type of command that it is. You can add query parameters if you want. You can customize the responses and the headers that you should be using. But one really nice feature is you can reference data structures that you've predefined. So here I've got a GET request. It's a REST API. Here I've got another GET request. This time I'm going through and I'm specifying some query parameters that I can use. And this is really pulling off of the data structure. So if I take a look at the structure, you can see how that's created. So the structure is nice because you can just take a sample JSON, drop that into the tool, and then it will start generating the structure for you, and it will predetermine the types. But of course, you can edit and change those if you need to. That's great and all. Once you've got this designed, but what do you do with it is sort of the next question, right? So most tools, what they'll be doing is they'll be generating open API standard syntax behind the scenes, and we do the same thing. So think Swagger and RAML, and this is what enables the portability of the API definition. So this is the contract that you're going to be sharing with other tools. So you could use this, for example, to load your API into the Azure API Gateway service. And we use it ourselves to bring the endpoint into Talend Studio for the implementation piece. What's really nice is that you don't actually ever have to touch this. It's 100% graphical. It does all that behind the scenes based on your inputs in here. But there's also a couple of other nice features that will help you get going. And this is where I'm talking about the decoupling of the process from the design process and testing from the implementation. Is you can actually you can go ahead and publish the documentation in our API garden. That means people can go ahead and they can start browsing your API, looking at what parts they can consume from it, understand the data structures, and you can create a mock. So I don't have a mock enabled because it's live right now. But the mock basically takes the samples that you saw in that data structure, for example, like here, and it uses that so that it basically queries that same structure and uses that to provide a response. So you can get an idea of how your API is going to operate before you're even pulling against any real live data. So what we also do is we generate documentation. So this is the consumption piece. So basically, and this is what we publish for you. This is where people will go in, they'll learn about the API, what operations they can do. This is an API for getting students from a university and getting some basic information for them. And then when you've finished your API, you can then go about implementation. But like I was saying, you can actually test it ahead of time. So if I go to, API tester, this is where you can actually start testing your API. So you can see on the left here, we've got like a series of options, a series of operations that we can run. And you can string those same operations together in a sequence. So often with an API, it's not going to just be one call. It's often going to be a series of calls, and the other one may be reliant on another one happening. Like think pulling a report. You'll send a key to get the report, maybe some information, and then it will generate the report and then spit it back to you. So the idea here is that you can actually string together scenarios. So here's a scenario using these different operations. You could go in and edit each of those, or you can just go ahead and play it. And you can see, hopefully you get all green and everything's okay with your operation. If you want to dig in and take a look, you can see, what's going on with the individual request. And there's sort of the example actual request that came through and the results that came through from the API. So that's the design, the test, and the documentation. It all happens outside of implementation. So when you want to actually go ahead and implement, this is one of the things that's new in the Talend Studio. If you're an enterprise user, you'll have a shared repository where all your metadata is stored. And so now REST API definitions are available in the studio. So this is a really nice feature because no longer do you have to go about configuring the definition. You just you pull your API directly from the designer. So if I went to do that, I'd do that. At this point, it's logging into the tool and it's seeing what's available. There's my API. I'd go ahead and I'd add it. So I've already added it here. This is a job. This is an example job for that API that you saw designed there with the structure. You can see I've got this is the actual endpoint. So this is what I could generate from that metadata object I showed you there in the repository. So if I bring this over here, you can see I've got those operations, my get, my delete, and my post. And there's some other configuration going on behind the scenes there. And then, so you define, but what I always think is like a strong point for Talend is if you have existing batch integration, for example, and you've got lots of, standard jobs that are going on, it's fairly easy to wrap an API endpoint around that. So you just put the T-REST request at one end and the REST response at the other end, and then you can put it through your original transformations. So just to go into a little more detail on the implementation side, if we look at this TXML map, you can see I've got my requests coming in, and I'm doing a lookup against. I'm using fuzzy lookup to actually pull the query response, and then I'm mapping that column row data coming from the database to the document body format that's required for the API. So here column row with a lookup, and here's the. I don't know how familiar you all are. Sometimes people are always doing column row, but we have a document format type. This is where you actually define responses, so that the API is serving up JSON or XML. So it's nice and easy to sort of put together an API and serve it up. So that sort of covers those stages that we were talking about in the slide. So if I just bring up that slide again for a second, if I can. Oops. Yeah, so we've done those stages, right? So we looked at it in Designer. We saw, that we can sort of do that design with sample data, and we can test it even before we implement it. But typically what you do is you implement it in the studio, and then you run some tests against that implementation. But then there's time to deploy it. Then you can go into the Talend Management Console and do the deployment. So probably are a lot of you on-premise customers today? Or community? Yeah, so if you're community, you want to use this. If you're on-premise, Talend Management Console is the cloud answer to TAC. And if we just take a look at that, I'll show you what deployment looks like for services in Talend. So let's take a look. So right now I've got this running locally just in my JVM on the machine. I'm going to stop that, and I'm going to log into the management console, where I should already be logged in, actually. Let's see. OK. So I'm not going to go into detail, unless you want me to, about the sort of Talend Management Console, because there's a fair bit to look at here. But it's, just think of it as TAC. And I'm going to bring up the tasks. And this is my API that I published. So basically, it's the same process through on-prem. You publish up to TAC, in this case, TMC. And then when it comes for an API, this is running live all the time, right? So you've got to deploy it to a runtime. And so what you do is you come in, you define the engine that it's going to hit, a bit like a job server. The remote engine then will deploy that to the runtime. So I've now deployed that to the runtime, and I can start. I should be able to. It should deploy soon, and I can start making requests to it. So what's going on here? We should take a look at the architecture of it. But basically, I've got. Let me bring up a slide on architecture. It's kind of buried down. So cloud's a little bit different, right? Because we take care of all the management of all the TAC pieces and the environments, the designer, the tester, the management of the jobs and the scheduling. And so you're just doing all your work in Studio as you would normally. And then instead of publishing to your on-prem infrastructure, you're going to publish up to the cloud. That code will be ready to deploy to a remote engine. So this is showing a virtual private, a VPC, to something like AWS, but it could be anywhere, right? You could be running this remote engine down on your firewall. The remote engine is basically secured to the cloud with a token exchange over an encrypted connection, just for the purpose of monitoring and sending logs back. And it obviously gives you the convenience of being able to place the engine wherever you need it in a secure way, without without worrying about having to open up ports or anything like that. So the remote engine, you've got a couple of different options. You could either, it doesn't show them on this diagram actually, but you could either deploy it to a microservice. You could also sort of set it up to sort of work with a third-party gateway. But really, what's really going to happen is most of the time, the remote engine is going to see the deployment request, and it's going to deploy it to a runtime. So in the example I've got on my machine, I'm just running the services locally here on this one machine. In the real world, this is going to be set up differently. But I've got a runtime, and I've got a remote engine. So the remote engines are all listed here. And this is configured so basically that when it sees the request, a little bit of magic happens, and it knows to deploy that service to the runtime. And you specify whether or not you allow microservice deploy or just Talend runtime deployment. So that is sort of the end-to-end process for API design, implementation, and testing, and a little bit on architecture. Next I was going to talk about continuous integration. Were there any questions?
Yeah, I have a question on, you deployed the endpoint. If you go into Studio on the endpoint,
yeah.
Are you still allowed to deploy the Swagger UI with that endpoint? Like if you go to right-click that, look at it.
Yeah, there's a...
Yeah, are you still if you expose that, does that end up doing what it used to do and giving you a simple Swagger?
Yeah, that was still, they haven't taken anything away. They've just given you this ability to...
Is it as complex as the Swagger you gave it? So if we build a complex Swagger with a lot of comments in it,
yeah.
will it show up on that UI?
Well, if you're pulling the contract, so I think the best practice recommendation would be to try and do everything in API Designer.
Right.
So yeah, it's going to show up the same level of detail because it's conforming with the Swagger protocol. So if we bring up the designer, so there's places where you can add commentary.
Right.
So I'd recommend you do it wherever there's a comment field in here. I mean, you could go in and probably start editing, but yeah, if you can avoid it, do it there, and then that's going to pass through, and you're going to be able to
So most of the time when I release APIs to people that I built in Talend, I do not just give them an endpoint. I give them the UI. That way they have something to play with. And
right.
I want to make sure I don't lose that.
Oh yeah, because they can then So because I see what you mean, because you're talking about the documentation. It's a little, you don't play around with it so much as you see what's available, rather than unlike with Swagger where you can try it out.
Yeah, we don't have enough licenses to give this to everybody
right,
that's using
right.
my API.
Yeah.
But when I publish my API, I want to be able to give a Swagger UI to them.
Yeah, they're not going to take any of that away from you. It's like we just enhance it by giving you a graphical way to edit it. Well, I don't want to keep everyone from their food, so I thought I'd go into continuous integration and continuous deployment, rather.
Well, what's the advantage of using a Talend cloud here? I mean, because those API stuff you can do it in enterprise also, right?
Yeah, so there's no you can if you're an on-premise enterprise customer. So the question was, what's the advantage of the cloud? Well, the advantage of the cloud actually is that we don't provide this with on-premise.
Okay, paid designer tester. Okay.
It's not something you can add on to on-premise.
Okay.
But in terms of like your existing deployments, there's been no change in the underlying architecture.
Okay.
So, and in fact, we're using elements of the ESB architecture that have been around the whole time, right? So the remote engine in the cloud, where is it? This remote, I believe the remote engine, it's actually using some of the same elements that we use for the runtime. It's a Carafe container. So yeah, it's the advantages, but there are some advantages to cloud, just in that you have all of the environments managed, and there's also another big advantage, I think. And I don't want to push cloud on everyone, but I'm obviously for it because it's also much more generous in terms of your upgrading and strategy. So with the cloud, I forget, as long as you're about a year within the last major release. So if you're it's like today we're on 7.1. I think if you're on like 6.4, you're still current, and you can run 6.4 against our environment, and you don't have to upgrade any of the components associated with that. So it's quite nice because you stay up to date in the cloud, and obviously you have a choice to upgrade when you want, but you don't have to sort of keep upgrading all your jobs all the time, every time you want to change the underlying infrastructure. So that's quite handy. But the architecture is the same, right? You still have a runtime. Yeah. There are some new things coming, and I guess I should talk about what's coming. So one thing that's coming is you're going to be able to containerize microservices. That's one thing that's coming on its way. The other thing that isn't in the cloud today, and we're not talking about it today, is management for containerization services against common platforms like AWS and Azure and those sort of things. But that's a different topic. So I don't have a demo for the next piece. It's mainly slides, but hopefully you'll find this interesting. So I'm going to talk about continuous integration and development. So for those of you that are community users, you don't use source control management or a Nexus repository. So some of this may be a little, outside of, what you're used to. For those of you that are customers, this will be very familiar, and I'm going to talk about it in the on-premise context, because that one currently supports the full end-to-end flow. So when we talk, continuous integration and development is really designed, for those of you who aren't that familiar with it, it's really designed for organizations where you have multiple developers building and working on jobs, and you want to make sure that you can carry that process through. Instead of being manual, you can automate it as much as possible. So it's about automating that whole end-to-end life cycle of the job. If it's a runtime or if it's a batch job, same thing. We typically see this with customers where there are lots of developers working on it, because there's more chances of them bumping into each other and for things going wrong. So this is to try and take a bit of that out of it. So I'm going to talk about product topology and roles. So that's the underlying infrastructure and how all the pieces connect together and interact. I'm going to talk about branch management in more detail and how that works with Jenkins and Maven for this automation. And then deployment and how Studio test cases work with it. So this is probably very familiar to a lot of you. Talend Administration Center, that's where all the projects are set up and managed. There's a database underlying it that it connects to sort of keep track of all that. We've got a Nexus repository. Nexus is where we store our binary artifacts. So that's when you've finished your work and you've got the binaries and they're ready to go, because we're a code generator. Git, it doesn't have to be Git, but I'm using that as our source control management. Typically, it's often Git these days. One thing that's new as of fall is they've added, the Azure service. I forget the name of it. Maybe somebody else can remember. What's that? Not Bitbucket. It's I can't remember the name of it. I've got a slide on it for what's new at the end. But it's the Azure service for version control, source control management is now supported as well. And then we've got Talend Studio, where you create the job. So everyone will be familiar with Studio. Nothing's changed there. And the development team. So, when the system administrator, so I'm going to sort of walk through the process from the perspective of the manual creation of the jobs and how that works. And then I'll start talking about automation. So the first thing is, the Talend Administration Center, a project is set up and it goes to Git. And there's a lot of animation on this slide, so forgive me. So once that project has been set up, so that means it's also creating a project in the Git version control. That means it's ready to go, and a Talend developer can log in, and then they can pull the model from Git and start working on the project. So often people think Git just contains source code. It actually contains more than that. So everything you see in Eclipse, there's an underlying XML infrastructure defining the project, the metadata, all the rest of it. So I'm going to refer to it as a model. So the model is stored in TAC. And then they can get in and they can see their repository and the jobs. And so what happens is, if you're working within a source control management system, it's a manual effort. They're going to pull the project from Git. They're going to start working on it. When they're finished, they're going to push it back to the branch that they're working in. And then when they're ready to actually publish the job, have it deployed, they're going to publish that binary over to Nexus. So Studio is responsible for all that. It generates the Java from the source model. It then builds the binaries, the jar files, and puts them in a zip and sends them up to Nexus, ready for deployment. And I know this is sort of old news to some of you, but it's important to sort of refresh ourselves when we're talking about continuous integration. So when you start adding continuous integration, then you need to start making use of the command line. So the command line, for those of you that haven't worked with it, just think of it as Studio, but without a user interface. So there's no Eclipse. It's just command line Studio. So that's what's going to enable Jenkins to actually to create the projects, to create the jobs, generate the Java, and build. So from that perspective, instead of Studio, command line is going to pull the source model down from Git, and then just as the Studio user did, the command line will be used to generate the Java and create the binaries and load them into Nexus. And that's Hadoop. It's the same thing. It's just in a different place. OK, so I'm going to go through some best practices for like continuous integration and development. I'm focusing mostly on continuous integration because that's where most of the work is done. So one thing we recommend is, and we'll cover this again when we go through the slides, you should have a development branch. The master branch should really be for releases. It should be tied to a release schedule. So it should be very stable code. The development's where you're going to be, the majority of the activity is going to take place in the development branch. Now, we're going to talk about how Jenkins is working alongside Git. You can either have Jenkins on a schedule. It could be polling, or you can, what's very common is a Git hook. And we'll cover that in a bit more detail. And then the deployment of the artifact should be pushed onto a Nexus repository. Yep, no, that sort of goes without saying. Yeah, and this is just a couple of recommendations. Try and keep the naming convention really consistent between the development branch in Git and the Nexus repository. So it's easy to sort of understand what's going on. So let's just step through it. So that was sort of a summary, but let's step through what's happening. So you've got Git, you've got Jenkins. This is the automation piece. It's the one responsible for interacting with those Talend infrastructure components. First off, you've got a master branch with all your sort of your release stable source code, and you've got a development branch. And then you've got the local branch. So the local branch is where you're going to do your work. You're going to pull from that development branch into the local branch so that you can start working. And then when you're ready, when you've finished your job, like I said, you'll publish to the development branch. And at that point, there could well be, this is very common, a push hook. So it sees that you've pushed and merged to the development branch, and Jenkins knows that it needs to start the process. So just like the manual user, Jenkins starts to work, but it's using the command line. So first of all, it's going to access that project, and then it's going to use Maven. So you probably know this, most of you, but like underneath, we're using Maven as the framework to sort of make sure that we understand where all the elements of our build are going to be, so where the source code is, where the dependencies are, and all that will be stored in the project object model. I think that's what it stands for, right? For the XML. And then, so that's going to do the generating the code. Remember, we're generating the code from the source model in Git. So we're actually generating the Java. And then the next stage, it's going to use the command line to actually build and test the package. And then if it passes, great, and you'll get a report saying that everything worked out. If it doesn't pass, then you'll stop the process. And then, so the next stage from there is to do the deployment, and then, so again, Maven will go about actually working with Nexus to deploy the binary artifact. And this is just pointing out it's good to keep those two things consistent, right? So you can find things, right? So, because it can very quickly get messy. And then finally, once everything's finished, the end of the process would be you push to the master, right? Is that me? Yeah. So again, this is just sort of a recap of how it works. You create your job in Studio. You've got Jenkins and Maven in the mix. And they're going to basically pull that source code from Git to create the job binaries and load them into the Nexus artifact. So it's just the things that the developer does in everyday context, but just using Maven to do that, and Jenkins. So this is sort of a close-up look to give you an idea of how it will work when you've got multiple developers, and it sort of gives you a better view of why it's important when you have multiple developers working. Because you have all this push and pull activity, and you're just going to make sure that you don't get any conflicts along the way. So, and anyway, I won't spend too much time on that. We probably need to keep moving, but it really is helpful, and it's really important to work in the development branch, right? But does anyone have any questions?
Can you go back to the other drawing
Yeah.
that looked like this?
Sorry, it's a lot of animation.
That
Yeah,
one.
this one, yeah.
So when you go to build fail, when you do the unit, that
Yeah.
is not in the master branch yet. It doesn't hit the master branch until you get past
Yeah.
deploy.
Right. Yeah. Exactly. That's a good point. So, what he's pointing out is that you get to this point. If it fails, you're not going any further, and at that point, just the process stops. And I don't know. Some companies, there's quite a lot going on here. So companies may do a number of different things. I don't really know beyond the fact that it's going to spit out a report in JUnit, and you're going to take a look at that report, and it's going to be based on test cases. So the missing piece from this diagram is the test cases in Talend Studio, right? So if you're familiar with test cases, I've got some slides on that too. But your test cases are really important for this piece. Understand, because that's what's going to determine whether or not you can move on in the process, and if there's been a failure.
If you do move on, you make your Nexus image before you reset the master, correct? Or do you reset the master then make your Nexus image?
I guess you could do it. You could do both. Yeah. Yeah.
Because you assume the Nexus image is clean.
Yeah. At that point, once you pass this stage,
It's clean.
yeah. So you could make the call. You could do the push to the master at any point. But it is a complex setup. It's not like a trivial thing for most organizations to do. But it saves a lot of time and pain.
And the BXYZ is your
In the
planned
long run.
release number. That's just whatever you plan your release number to be.
Yeah.
And then your Nexus gets the release number.
Yeah, and then usually the master it's usually tied to your major release, your release version, or maybe it might just be a Jira, request, something that makes sense for the organization. Any other questions? No.
Can you go back or go forward to the other image where you had concurrent development? Yeah. So.
Oh, there's some recommendations along here, actually.
Yeah. So there's 3 developers working on the same.
Yeah.
The same module, right?
Yeah.
How? I mean.
Yeah, it is.
And it's pulled out of the development branch for each user.
Yeah.
How does it keep?
Yeah. How does it keep track of so they don't step on each other?
Changes.
Yeah.
Developer 1 can make so many significant changes. Developer 2 might do something completely different. How does it?
Yeah.
What happens?
I'm glad you brought that up. So there's a couple of recommendations to help with it, but so the basics of it are, Talend just exposes Git functionality. So when you check back into the development branch, it's going to prompt you to resolve conflicts, but that can be a pain. So rather than resolve a lot of conflicts, the best practice would be have one developer working in a job at a time, if you can get them to. Or at least if you've got multiple developers all working, but you can still resolve the conflict. So even if they do it, right, you're not in a situation where they're gonna, where you're gonna lose or get things mixed up. But just generally to make it easier, if you could encourage them to, work on one job.
I'm a DI, pretty much a DI developer, right?
Okay, yeah.
So when a lot of our design is, driver jobs with a lot of sub jobs, right? So I can see multiple developers working on different, subjects.
Yeah,
right? So
yeah.
maybe,
That would happen. I mean, so you do have the conflict resolution. It's going to give you a detailed way to actually resolve that conflict. It's designed for that. I mean, I'm just saying in the ideal world, have them segmented as much as possible. Another sort of subtle point is that I didn't realize this initially, but actually when you check in and check out, when you pull and push from the branch, it's the whole project. It's not just the individual job. So one thing that we'd recommend is that before you start working on any job, make sure you pull down from the master or the development branch, right? Because otherwise you're going to have more to resolve. So it's all about trying to reduce the amount of things.
To reduce the conflicts, people always have the handshake agreements. I'll touch the bottom, you touch the top.
Yeah,
Stuff like that.
yeah.
So
You can work it like that,
yeah,
exactly.
you can work with each other as friends and say, you know, I'm here to hit this part, you're
Yeah.
there to hit that part, and we won't affect each other because neither of us are touching anything that's common.
Right, right. And then if it's a really big organization, you might want to split up into projects. Yeah. But then even within the project, you're going to have the scenario that you're referring to. You need to have a handshake. And so this is this is for people who use Community and don't really ever see this part of it. But this is just what it looks like, right? When you're working with a version control repository, you check it out. You'll see that you're working like this. This person's working in remote mode, so that means they're actually connected to the Git branch. They should be working in local mode most of the time. That's when they've pulled down. And then and that's just a view of you selecting your project up in Studio. You'll see actually the number of modifications, so you'll have some kind of way of alerting. If you go on a job and you see there's like a bunch, this time you need to check in, you'll see what you need to check in, and then there's some recommendations there. So I think I'm going to sort of start wrapping it up soon, but the next part of this is the deployment part. So that was all to do with the continuous integration. The deployment part's a lot more simple, I think. It's just Jenkins, again, taking care of, it has to create a task, right? So this is in TAC, if you're familiar with TAC. It's going to create that task of the job conductor. So that, TAC's going to have to do that. It's then going to, it's going to get that artifact from Nexus, because that's all happened in the continuous integration on the previous section, and then it's going to create it to send it to job conductor. You might, rather than be running it, you'll use the deploy option just to deploy it, and that's available through what we call the meta servlet, but it's really think API, right? So that's the TAC API, and if you're in the cloud world, it's going to be the Talend Management Console API, which is a proper REST API. And that's sort of it. Oh, test cases. So test cases and where that fits in. So this is in this section here that you brought up earlier, when you get the JUnit report. The way that's done in Talend, and this will be the last thing we'll do today, and I'll just sort of show what's coming. So test cases, this is sort of the hierarchy, the structure. You have one job to many test cases. You have one case to many test instances. And then you have one, and then it's, the test case is essentially a job. So what does that look like? So this would be a test case scenario, right? So maybe your test case, this is very simple, but like just a transformation. And you have some inputs and some expected outputs. So what you'll do is you'll basically create, it's a bit like a joblet. It is a joblet, I think, really, under the covers. So you're creating this abstracted layer for the inputs, and then you'll have the output so that you can get the expected result. And then you'll have everything that's happening up to that point before it. But it's really, that's the test case. So I've got a couple of views. One is just of a tmap instance, and the other is one of a sort row and tmap instance. So this would be so in the hierarchy structure, this would be a test case with an instance of a tmap, and then in the same test case you'd have the tmap and the sort. So this is what it looks like in Studio. There's the job, there's the test case. You've got the tmap and the sort. And then, sorry, I misspoke earlier. It's the test case. Yeah, these are the two different test cases. And then you have two different instances. And each instance is going to have a different input and a different expected output. And that's what you're going to use to generate that JUnit report. And that's, so that's how it is. So what happened recently, sort of what's new is we got, that's what I was trying to remember of, Azure DevOps. So we got support for Azure DevOps, right? So that's very popular. We've got this Maven plugin. This supports API testing as well. So everything I've shown you is focused really on batch, but it also works with runtime and deployments. We have the ability to deploy, routes and services to the cloud as well. I mean, so that's fairly new. And we've got we also support now JFrog Artifactory, and then. And then this, I didn't really cover this today. If you, when we're eating, feel free to ask me about containerization and what we're doing there. But there's a lot more support coming for containers. And it's very easy for us to do. So, okay, so that's all I have today.